Welcome to Learning with Philemon. Since its invention, plastic is used constantly in our everyday lives in a variety of applications. In this video, we will see that plastics are polymers that are made in a process called addition polymerization. Let's begin by defining a few key terms. A monomer is a small molecule that is joined together with other small molecules to make a long chain. The word comes from two Greek words, mono meaning one and meros meaning part, one part. A polymer is a long chain made from many small molecules. Poly means many in Greek, so polymer means many parts. Let's imagine that the monomer is this box. Joining many monomers together, we get this polymer. A polymer consists of many monomers joined together. Note that the black line represents a chemical bond between the monomers. Now let's look at some examples of actual polymers. The first example we will look at is called polyethene. The polymer is made from the monomer ethene, C2H4, an alkene. Under the conditions of high pressure, heat, and a catalyst, you can join many ethene molecules together. You are not required to know the mechanism for this process, but to know that the double bonds of each ethene molecule break. The electrons involved in the double bonds are used to form single bonds with neighboring monomers. These new single bonds formed are colored red in the diagram. We have gone from many alkene molecules to a long chain alkane. Note that in the diagram, we only see 4 repeat units, 4 monomers bonding. The end monomers could continue to bond. To show this, we draw parentheses through the middle of the outer bonds. Below, we see another way to draw this polymer. In the brackets, we have 1 repeat unit. Notice that the double bond is broken. On the outside of the square brackets, we have the letter N, any positive integer. The name of a polymer always starts with the prefix poly and ends with the name of the original monomer, in this case ethene. This type of reaction is called addition polymerization. Identical monomers are added together to form the polymer and no other side products. The most common monomers used are alkenes. Polyethene, also known as polyethylene, is the material that is used to make plastic bags because of its durability and ability to expand. Now let's take a look at another example. The monomer used to make polypropene is propene, C3H6. A common mistake when drawing polymers from monomers that contain a chain longer than 2 carbons is to connect the monomers using the end carbons. This is incorrect, as the monomers bond via the carbons involved in the double bonds. In fact, to make the structure work, I had to move around some carbon-hydrogen bonds. My recommendation when drawing monomers is to draw the 2 carbons involved in the double bond on the plane, as seen here, and any other groups bonded to these carbons above and below. This makes it easier to see which carbons bond to make the polymer. As can be seen, the CH3 group is not involved in the bonding between the monomers. Although polypropene differs from polyethene only by a CH3 group, its properties are different. Polypropene is used among other things to make bottle caps, because it is a tougher material than polyethene. For more addition polymers and their uses, check the LibreTexts link in the description. Although the polymers discussed are useful in many ways, they do have their drawbacks. These types of polymers are not biodegradable, which means that they cannot be broken down by bacteria. Plastics are often left in landfill sites and left to decompose over hundreds of years. Unfortunately, in some places in the world, to get rid of the plastic more quickly, it is burned. The combustion of some plastics releases toxic gases. Unfortunately, plastic waste also ends up in oceans and is responsible for the death of thousands of marine mammals every year. To reduce waste, we can all try to recycle and reuse plastics as much as possible. Scientists have also developed biodegradable plastics that can be used for some applications. For more information on the environmental issues, please read the articles in the description. Thank you for listening. To consolidate your learning, try to answer the questions in the description. If you haven't already, please subscribe for more content. Stay curious.